Algorithmic trading with Python. Day 4, we're going to be building some AI. I'm actually really excited because today's the day that we start training the model. We've been practicing to get all of our data in the right shape and size. And you see here on the screen, look up there. We're up there. You can see this is the data. We got it in the right shape. We do have a few things we want to modify and make a little bit better. That we've got good news. We've got really good news, everyone. We've got great news that it basically is good enough the way it is right now. I'm really excited. Hey, how's it going? SAQ 3000. Happy to see you. Welcome back in. We're going to be training our data today. We're going to train the model. I'm really excited. We've been working on, we've got it. We're really close. We're really close to getting our AI working. We've got the model all set up, basically. We've got the model all set up. We've got the data set up for the most part. Now we just need to merge the two. We need to bring our data into the model and we got to train it. We've got a few things to do. I'm coding Python shape creation with Claude. That's a great way to do it. That's a great way to do it, to actually use the AI directly. Use the AI to write as much code as you can, because guess what? It can do it for you. Why bother having to do it yourself when the AI can do it for you? I suppose there is one reason. It's just maybe for learning purposes, but also for fun. Maybe for fun. Coding is fun still. So you can do some coding on your own without the AI, but also using the AI is going to help you a lot as well. Because I actually, check this out. This is really neat. So I've been doing coding for many years. And as soon as the AI started coming on, the AI code generator started coming on the scene, we did some amazing new ways to learn. Let's take a look here. All right, so we want to shuffle our data. We also need to learn how to use the to device. I've done this before in the past, where we capture the device, which is going to be the accelerator, right? When we're using PyTorch, and we want to accelerate our model and make it run faster by using a GPU or a TPU, we need to send our data that's currently in RAM on the system bus on, and we need to move it to GPU memory. And so that's what we need to do with this two device. I think so. SAQ 3000. I think it's interesting. I'm really excited for this. This is going to be cool. And then once we do this, we'll be able to see some initial. Is it going to learn? Do you think it's going to learn? I think it's going to learn. Thank you for all the likes, you guys. Appreciate. Or here we go. What we're going to do now is we're going to start by doing the data loader. We're going to do the data loader first. So I did pull in some instructions. So we do need to import a data loader. Let's see. I pulled in some instructions. Here we go. So let's see here. So we need to pull this in. Let's copy and paste this here. We'll do some copy and pasting over here. And so we import our libraries properly. Got to import our libraries. Also might want to use SGD instead of AtomW. Because this is something I'm familiar with in having it takes a little bit longer to train, but it actually might be worth it. It actually might be worth it, especially since we're going to be shuffling our data. We're going to train, we're training our machine learning model or AI model, our algorithm model. So yesterday we succeeded in preparing all of our data, right? So we got all the data. So you can see here at the bottom of the screen here, right here, this section, this is all the data that we needed. It's all the important data. So we've got it into the right shape. ResNet, what we're using is PyTorch. We're using PyTorch. And we're going to be, we've got a simple, we're going to be using here. Actually, I could pull this over here so it looks a little bit better. So these are libraries that we're using. YFinance for the data set, PyTorch, the transformer for full self-attention. We're going to use Gemma Embedding for the sentiment analysis. I'm really, I see. Cool. Yeah, I think so. I think it's really cool. Then we're targeting high volatile market with lots of news events, because that's what's going to trigger the data, right? We need a lot of data, high volume, so that when we place our sell order, it's very likely to be matched with a buyer, with a buy offer. When we place our sell offer, we want to make sure that it gets sold as fast as possible. I guess if we don't have to, it doesn't have to be super fast, but a reasonable amount of volume, which just means there's enough trades to be able to place our sale so someone will actually buy it. Are you going to be testing it with a live account eventually? Maybe it's possible. KO'd, maybe we might do it. We might, but for now, we're going to test it. Today we have one. Thank you for the likes, you guys. We've got a plan. We've got a plan for today. The plan is we want to make sure to get these to-do items finished, which will be here. These to-do items right here, these ones. All right, so we basically want to start the training process is the idea. And we need to be able to do GPU acceleration And we need to be able to shuffle the data for stochastic gradient descent. And I'm thinking about, I probably want to use the SGD optimizer over the Atom optimizer, but we're going to try Atom first. We'll try Atom first. We'll see how it goes. So let's get our data into, so we're going to need to do tensor data set and data loader. So I do think I need to run this here. Like I need to grab our features and labels and then put it into, let's see here, something like, so I think it goes features and labels like this. Yeah, exactly. Thank you for the likes, you guys. And then I'm not sure if this is this the data set? Is it like this? Or does it what does the tensor data set do? Let's go back here. I did have this up here. So I don't think I need to do that. Okay, so it is just data set. Okay, perfect. All right, so you've got the data set, and then we need to put that data set into a data loader like this, and then shuffle true. And then we have a batch size. We could do a batch size of 16. We don't need to be a batch size of 16. We could probably do like a batch size of 8 or maybe even 4. Let's do a batch size of 4. I think that's a better idea. 4 now. All right, so now, actually, we're going really fast. We might finish quick today. And then I'll be able to figure out what happened with our rollback earlier. Now that we got the data loader. Thank you for the likes, you guys. We don't need that. We already have this. Model. Oh, wait. Torch.tensor. I wonder. Or wait. So we've got a data set here. We need to do it different. Okay. So we got our model. Do we have our model? Did we define the model? We did. Okay, we defined the model. All right. So so we need to pull this out. Let's pull this over here. Okay. You know what? Thank you for the likes, you guys. All right. I think we're ready. I think we're almost there. Oh, this is so exciting. We're almost there. Okay, so I need to put the data loader into a device. So I need to figure out how to do that really quick. I'm not familiar as much to do this. Okay, so we got batch size data loader. Looks good. Shuffle, true, iterate. Looks good. Features. Okay, so data load. I need to do that like this. So I do need to do like that. I do. Batch features, batch labels, and data loader. Okay, perfect. Let's pull this over here. And then thank you for the likes, you guys. So instead of text, so we do features like this. And then logics, and then we've got our labels. Where is it? Where are those? So I've got our batch labels. We figured that out. Here we go. Batch labels like this. Okay, and then we run backwards, step the optimizer, and then see what our epoch is and our loss rate. Perfect. What are our probs here? Okay, so probabilities. Okay, so this will give us the output of the best possible answer detached to CPU. Perfect. So I need to, does it automatically do that? Let me double check. Maybe we don't already, so device. I'm pretty sure, so we do have a device. So what I have to do is figure out what the device is. Okay, so torch.toDevice. Here we go. Then where is, let's see here. Okay, so it'll default to CPU, of course, but I want to use the GPU again. I want to use the GPU. Let's make it fast. Okay. But isn't there more to it? Because I also, tensor.to, that's self-device. Okay, so it automatically takes the tensor, automatically puts it to the device. So all I need to do is find a list of device features to items. Maybe text is a string iterable, but I put it into a data loader. It is an iterable though. We might have to make some changes here. We might have to change some of this here. We'll see. Okay, we don't have to worry about that. That looks good. Embeddings, we're all happy here. Okay, I think we're good there. So all I need to do now is figure out in PyTorch, how to get, let's see here, PyTorch device list. Here we go. How to get the device list in PyTorch. Let's see if we can do that. See here. So we've got a CUDA, but what if we don't have CUDA? So torch.CUDA is available. Okay, so then, how, let's see here, Intel extension. Okay, so we don't need to worry about that one. IPX. What about, I need a list of all available devices. List all available devices. I need a way to do that. That's what I need. I need a way to list all the, okay, so backends.mps. So that's the one I know I want to use. I'm pretty sure I want to use MPS, but I want to list, so I'm pretty sure this is the one, at least for now, this is the one, because I'm running on Apple, right? I'm running on Apple MPS. Okay, so I think torch.device MPS. Maybe we can just copy and paste this right here, parameters, and then I say device, device, like this is going to be that torch device MPS. So is that it? No, that's not. That's the wrong. I put it in the wrong spot. We need to put it here. We need to put it right here. I'm pretty sure. Actually, let's double check. Where do we, is it on the forward? Actually, I'm actually kind of curious. Where was it? Do you guys remember? I don't. Okay, so it's not there. Oh, no, it is there. It's right here. Okay, perfect. We did it. Okay, so I'm pretty sure we got it in the right spot. So it's here now. And I think what we could do is, what happens here? What happens? So we're not all the way there yet. We have more things to do. We're not done yet. Okay, let's just print a couple of these for debugging, just in case. So we got our data loader. Then we've got the batch. So we're using our data loader, and then we put the batch features in. Looks good. And then we have our output and our labels, which is going to do our loss. What's going to happen if we click run? All right, here, let's do this. So Python train. Is it going to actually work, or is it? We're going to find it. Hey, let's see if it works. Is it going to break? Is it going to break? I don't know. We're going to find out. We're going to find out. I'm actually really excited. I'm really excited. Is it going to work? Did we already do it? Are we done? No, I figured as much. All right. I knew there was going to be a problem somewhere. I knew there was. I'm like, it's too simple. It's too easy. Okay. Where's the problem? We got to figure it out. Yo, I was just learning PyTorch. Yeah, all right. That's what we're doing to do. That's what we're doing today as well. Having trouble with some of the typings. Aha, that's what we're doing. Is your logits typed, or is it just Annie? Oh, well, it's, I don't know. I mean, it should be, I think, let's find out. So here's our logits, where is it? Logits, here, okay. Which runs the model, which should just be forward, right? So it's just going to run forward, I assume, because I'm not familiar, but I'm pretty sure it's just forward, right? So here is the forward, and then it returns the classifier. Let's jump into our code because we need to figure out what we did. There's an error. We got to figure out what the error is, just like earlier today when we had to roll back some code in our infrastructure because we had an issue. And so that also is the reason why the main tasks for today, we want to make sure that we at least get our AI running. We want to train the AI. We're really close. Thank you for all the likes, you guys. All right, so here we go. Where is the issue? List at a size 0 tensor on dataset. Oh, what? No. Oh, come on. So our data loader is having an issue? Is that what it is? Our data loader? Oh, maybe it wants it to be a different kind of features and labels. Maybe we need to use NumPy. We might. So now we do have some tasks here. We need to actually get this to work. I'm really excited to get this to work because we could profit. We could profit from this, you guys. All we have to do is figure out what broke. Thank you for all the likes, you guys. Thank you for the likes. And we're going to jump back into this AI algorithm. Let's do it. Okay, so where is our problem here? Dataset assert user site package size tensor size. Okay, so list object has no attribute size, but that is in the dataset. So it is actually erroring out on line 65. All right, so 65. Let's go to that right here. Oh, look at that. Okay, we've got good news. I think we know exactly how to fix that. Let's jump over here really quick. So I think it's right here. So we probably need to put NumPy around it, maybe, or we need to do just torch, maybe new torch. So what we could do is just throw NumPy around it and do this. Let's throw NumPy around it. I think we could do it like this. All right, so float, versus long. Oh, interesting, float versus long. We need to pay attention to that. That is a thing. Okay, so here, like this, like that. We go like features array, like this. Like that, and then we're going to put NumPy around it like this, np.array. There we go, like that. Did we import NumPy? I don't think we did. That one. Now we need to do labels as well. Actually, you know what? Just to make it so it's easier to read, we're going to do this so we can pipe it around a little bit easier. Paste that into this. We need to we need to do a long. It's got to be long over here, right? Long like that. There we go. You guys, do you think that's going to work? I think that might work now. I think it's me better. Let's find out. Did we fix it? Is it going to work now? Is it going to train? I don't know. I don't know. There's so many things that could go wrong. There's so much code that's untested here. Okay, so we got a problem. We already got a problem. Features float. Wait, NumPy. Wait, can't convert np indie array to. Oh, because it's a string. Oh, right. We don't need to do that step. Whoops. All right, let's see here. We don't need to do that. We're being silly. There's no way to do that. There's no way to do it. There's absolutely no way because it's text, right? This is text data. So it can't be a tensor data set. It can't be. So we've got a problem. We've got a problem. Tensor data set. We need a different kind of data set. I think it's got to be something else. Or we have to do it ourselves differently. I think that might be what it is. Or we have to embed it before. We might have to embed it before. So we have to change things around, you guys. We might have to change things around. To the rescue. I think that's what it is. I think that's what we got to do. I'm pretty sure. I am pretty sure. Here we go. What are we going to do here? How are we going to take care of that? I think we have to do it here. So what we probably could do is after we embed it with this, we can convert it. So, but this is a forward. This is a forward, and it's taking text data. It's taking text data. So we might want to figure out how do we do that. So these are features, right? Features and right. So this is our tensors to device. So what we could do is, I think I have a better idea. Instead of using data, instead of doing this, because we need to be able to get, I want progress. I want to see progress. Let's jump back into our code here. So instead of doing shuffle, we're going to demote this. And we basically did this. I think we're good here. I'm pretty sure we're good here. I think we can, let's see here. We're going to do green check mark. Yeah. I think we did that one. This one is still up in the air. We still don't know. We still don't know if it's possible. We don't know yet. We know it's possible, but we have to change up. We have to change how we're doing it. We have to change how we're doing it, you guys. So we'll do that differently. Instead of this, so let's go ahead and comment this out. Let's comment all this out and save it for later. We'll save that for later. So we don't need this. So we also don't need that. So let's bring this back in. And then instead of we actually still do want to batch though. That's the thing. We want to batch it though. So you know what? I've got a better idea. Let's do this. We can do this. Wait, didn't we have a really good batcher? We had a really good batcher previously. That we already wrote on stream. We could just use that, you guys. So using strings directly in features tensor set is generally not optimal for machine learning models because obviously we can't do it like that. But we can do it like, so we got strings, we got label encoder. No, that's not what, okay, so it didn't quite get it right. That's not what I was asking. Tensor data set, different data set types. Let's see if there's, we've got in PyTorch, tensor data set, alternatives. Let's see if there's some alternatives. Yo, what's up? Potish, how's it going? PyTorch data set is a convenient way to wrap multiple tensors in a data set. Yep, in a data loader. But, however, my data loader is going to be something different. I need tensor, or we've got a tensor dictionary. Provides a dictionary-like structure for handling collections of tensors. Nope. Okay, so I've got, why is it called shuffle and not parallelizing? Because it is, it's actually randomizing your input, now your training data, right? So your features and labels, your input data and your target data, right? So it's going to shuffle that and keep it all aligned. So that's the thing, you got to randomizing it. And parallelizing it would mean that it's going to be doing some work computationally at the same time. And in this case, it's not doing that. That particular function is just shuffling the data. It's just shuffling the data, everyone. So a data loader, can I do data loader with strings? It says data set. I want to see what kind of data sets are available. It's probably not, iterable data set? Iterable data set, maybe. Let's see here. Let's take a peek. Maybe this is something we can use here. This is it right here. Okay, so it's called model. This is it. So we've got all of our code. This is our shuffle code right here. We wrote this live on stream and it works very well. Right here, that's all it takes is just this little smidgen right here. You just need this little smidgen of code. That's it right here. Isn't that crazy? So we could probably do this. So we could copy and paste. So we got epochs already, and then let's do batches and we're good to go. And we can probably grab this right here, I think. That's it. I think we're good with that. And so we don't need to use dataset anymore. Right. We are in the role of CTO at my company, and I often help debug or help assist teams. And in fact, I'm streaming right now when I should be working on a very specific bug that happened because we had to roll back some code the other day. And I do want to get back over to that. I'll be waiting for the entry-level intern. Cool. Sounds good. We'll let you know. Thank you for all the likes, you guys. So we're almost there. All we have to do is just do a little bit of data operations here, and then we should be able to get it into our inputs and targets. We should be able to do that. So do I already have our features and labels? So we got our inputs and targets here, which are going to be features, labels. We're going to stochastic. We got and the length of the features, perfect. Permutation, I think that's good. We've got NumPy. We're good to go there. We've got NumPy. So we got our inputs and targets, features and labels. I think that's it. There's nothing else we got to do there, right? So all we have to do is now we got the features and we got the batch size. What is our batch? So we need the batch size. So I think we'll just say, yep. Batch 4, perfect. Batch 4, perfect. There we go. We're building ourselves our own algorithmic trading AI with Python today, and we almost got there. We got all the data. We got it in the right shape. Now we just need to put it into our model, and our model is we're using PyTorch transformers with the Gemma embedding for sentiment analysis. I'm really excited. I've never done this before. Is it going to work good or not? I don't know. I think it's going to work very well. I think it'll work very well. Okay, so we need this to be inputs like that, and then we need this over here to be target. There we go. Not targets, just target. There we go. Just target. All right, target and inputs. So is that it? Is that all we have to do? I think that might be all we have to do. We might have done it. Is it for real? We are coding our own algorithmic trading AI with Python using PyTorch transformers. I'm really excited. I think it's going to be really cool. Gemma just for sentiment is probably overkill. I know, isn't it? But we're going a step further. So we got our prices and headlines, but we also grabbed some extra data. We grabbed the summary as well. And then we have our delta. So you can see here, that's a 0.23% gain in the price difference over 5 minutes. So if you spent, say, let's just say in this case, $100,000, you would make $257 in 5 minutes. And just 5 minutes is not defined. We're getting closer, you guys. We're getting closer. Epochs, here we go. Wait. Epochs 10. Let's just do 10. We'll just do 10. Perfect. Well, it's just a temporary dip, but it's all coming back, and it's going to come back with force. It's going to be amazing. Hey, what's this stream about? Okay. So we're building an algorithmic trading AI using Python and PyTorch transformer using the Gemma embedding model. And our inputs are going to be historical price data, news headlines, and maybe foreign policy events. We haven't grabbed that yet, but that's a future to-do item. Our signals or our target outputs will be supervised learning to sell, hold, or buy signals. So we'll have an output classification layer, PyTorch transformer with a Gemma embedding input layer. That's what we built, and now we're trying to train the model. That's what we're trying to do. We're trying to train the model. So we're almost there. We almost got it. And then once we get it and we start the training process, we'll see how it works. Is it going to work? Did we get it? Is it going to have another error? I don't know. We got another error. No. Well, we'll figure it out. Okay, I think we can figure this out. This out really quick. We'll say print stochastic. And then we will break, and then we'll be done there. We'll break and we'll be done. Let's see, because we have to figure it out. So it seems like it had a problem here, right? On targets, on line 81, it was, let's see here, 81, features, right here, features. Okay, so it was this right here I had a problem with. Okay, rename this train.py, so we got that. We're good to go there. All right, so let's see what our stochastic looks like. What does our stochastic look like? Oh, so our features here. Let me double check. Let's go back to some of our code. We have to review some of the code that we wrote previously. Where's that at? Was it here? No, it's not here. All right. So, what we could do is we can go. It's in our Discord. Thank you for all the likes, you guys. So let's go back to our free. Here we go. And it is not that one. It is going to be around here somewhere. It's one of these. Here it is. I found it. Visit site. Okay, here we go. So we just need to grab the model, and then we need to take a look here. Okay, so features. I'm pretty sure this is fine. For layer, blah, 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 layer, stochastic, random. It looks good. Thank you for all the likes, you guys. Appreciate it. So what we need to do is just take a peek and why this part is having a problem. It should be perfectly fine. Oh, interesting. Input. Okay, no, that's fine. That looks good. All right, let's jump back to our code here. We'll figure it out. I know we will, because we will. We will succeed. We will succeed. All right, let's try printing this here as well. So let's do inputs. We'll try inputs. Thank you for the likes, you guys. All right, let's then break down here, and it will probably crash. It'll probably crash because it had a problem right here. So what is this? Should totally work perfectly fine, right? So but features. Let's see. What is our features? Where is that? It's right here. It's right here. It looks fine. That looks completely fine, right? Doesn't apply nearest k neighbor, or the k nearest neighbor algorithm. Oh, Sammy, thank you for asking about that. I don't think we need to do that. We don't need to do that one. I'm pretty sure. Thank you for all the likes, you guys. I'm pretty sure we don't need to use k-means nearest neighbor. K-means. I don't think we have to do k-means nearest neighbor because we have already identified all of our data set. We already have our data set identified, so we don't need to do that. All right, so integer scalar arrays can be integer scalar arrays can be converted to a scalar index. Really? Okay, so does that mean that we have to do something different here? Okay. So how do we go about that? Thank you for our likes, you guys. So if we do that, so this is saying that in that case, so let's try this. Actually, we need to try this. We need to do this really quick. We need to open up Python to debug this. We got to Python debug this. And then I have to get going and do some extra work. Import numpy as np. And then we go paste. And then we don't have features, but we'll just say like 10. We don't need 10. We just go like this. Here we go. That is an indentation error, which is really okay. And then we'll just copy and paste this here really quick. Looks good there. Okay. So then what we could do is, so we say 1, 2, 3, right? And then we bring that in here, and we should see a number. It should return a randomized index only. So interesting. Is it because it needs to be numpy? Is that what's going on? Maybe you need to transform it. Yeah, you're right. We do. I think we need to transform it. You're right. Import numpy. Import numpy as np. Oh, wait, we already did that though, right? We already have it. Okay, so what we can do is check this out. np.array. Is this going to be the trick? No. Wait. Oh, because I got to type it properly. I got to type it correctly. Okay, let's clear the screen. Out of range. I know why. Okay, that means it worked. That means we figured it out. The problem. We did have to transform it this whole time. Isn't that cool? So answer. Let's print out stochastic. What does that say? Yeah, 1, 2, 3, right there. 1, 2, 3. So stochastic is 1, 2, 3. Perfect. We're looking good there. Thank you for all the likes, you guys. This should work. Oh no, it won't, because here we go. np.array again, right? That's what we got to do right here. And now, there we go. That solved it, you guys. All right, here we go. We are gonna figure it out. We figured it out. We're gonna figure this out. It's because it's not native Python. That's why I never knew about this. When we learned this earlier this week, is because it's not native Python. The whole time I didn't even know. Watch this. Boom, boom, fixed. Right? Boom, boom, fixed. I don't even need to worry about that anymore. We've got to do the same thing here. Same thing right here. Fixed. There we go. We did it. All right. Are we ready? Yo, let's go. Thank you. That's actually right. We had to transform it. We didn't have it in the right shape. I had encountered this previously, so I remembered it. Thank you. Thank you for your memory. You saved us. You saved the day. Thank you so much. All right, here we go. All right, let's see. All right, Python train. Is it going to work this time? We got really far. I don't see why it wouldn't work now. Okay. Is it going to train? It's doing it. It's not crashing. Oh, damn it. No. All right. Where did it fail? Not numpy ND array. Must be tensor. All right. Target argument position must be a tensor. Okay. So I think we can figure this out. It's just we're almost there. We almost have it. Okay. We've shuffled the data and it's gotten the right shape, right? We got the targets in the right shape. So now all we have to do, since this is the batch right here, right? So the batch size is going to be 4, right? And then looks good there. That'll totally work. That totally works. All right. So in features, looking good. All right, here we go. It's so close. Thank you for all the likes, you guys. We're so close. All we have to do is just finish this one little bit. I'm pretty sure it might, no, it's not target. It's not target. I think it's this part right here. I think this is the part we need to fix. I'm pretty sure. Let's double check. Line 90, it says. Line 90. It's this one. Targets. Oh, is it? Is it really? Targets. So targets and inputs. It's right here. Okay. So it says this is the problem. How do we fix that? Loss criterion. All right. I actually don't know how to fix this. Uh-oh. We've got some issues. How do we fix this here? Let me look through the code here. Let me read through some of this. It says maybe must be tensor, not NumPy. Okay, so if it needs to be a tensor, we need to move this. Okay, I got it. So we just need to look up PyTorch tensor and then to device. Is it to device? No, we don't need it to be on a device. I think we can just do it like this. It could be on a CPU, right? Just on a CPU, because we've got targets and we got our output. And the model, I believe, let's really open. Okay, we're getting close. I think we're figuring it out. So the model returns classifier pooled. Would this include, let's see here, clamp? Okay, so that, I think we're fine with that. Okay, I think we're good. So all we have to do is convert targets into a tensor. How do we do that? All right, PyTorch, convert NumPy to tensor. How do we do that? That's all we got to do. Let's see here. From torch.from numpy. Okay. Is that it? Is that all we got to do? All right. Let's make it easy. Let's make it super easy. We'll just do it right here. Boop. Like that. Just like that. Okay. Let's run it again. Are we gonna get it this time? Are we gonna get it this time, chat? Is this gonna be the end? Did we do it successfully? We're gonna find out. We're going to find out if it works. Nope, just kidding. Expected floating point type for target with class probabilities and got a long. Okay, so it wants to cross entropy loss. Let's see if it works this time. And if it does, okay. Wait. All right, we made progress. Expected all tensors to be on the same device, but found at least two devices. We got an MPS and a CPU. Okay, so I think we have to move. So this is a NumPy thing. Is this a CPU? I think this is still in the MPS. So since that's an MPS, let's see here. I think maybe we could do this. Maybe we could do it like this. Let's see here, like that. And then we say target.to device. Something like that, maybe. Is that how we do it? MPS. Here we go. Let's try it. Let's see this. Device. Would we save it? We do. Okay, so we have it here. Self.device. Wait, but let's double check. Self-device. Here it is. Okay, perfect. It's right there at the top. Okay, so we can say model.device, target.to device. That should do it. All right, did we get it this time? I don't know. I'm suspicious because we have not been working so far. All right, is it going to work now? And then we'll be able to end stream. And we'll head off into the wind. Okay, tensor object, no attribute to device. Okay. So, okay, let's do a quick little Google here. Let's Google that real quick. Let's Google this. Let's make sure that we can, we need this to, let's see, how do we do this? Device, yep, so we got device, model.to device, target.to, okay. Let's try .2. Maybe that's better. Something like that. Let's see here. Like that. Is that better? Thank you for the likes, you guys. Is that it? Is that what we got to do? I don't know. We're going to find out. Thank you for the likes, you guys. We're so close. We are so close. We're just trying to get used to the framework. We're not used to okay. Cannot convert MPS tensor float 64 to MPS framework. Doesn't support float 64. Please use float 32. Instead, and paste that here. We're very close. Let's see. Just a few more bits. So we can do that model.to device to float targets.float.to. Okay, so we just had to add this little bit here. We just have to add that little teeny bit there. Okay, so close. We're so close. All right, was like that. Float to. All right. This is silly. I mean, come on. If it doesn't support it, at least automatically convert it for us. It's a framework. It's supposed to be beneficial. It's supposed to be beneficial. All right. Here we go. See, this is why Keras is easier to use. Keras is easier, and you don't want into these like little problems. These little problems. Okay, another problem. Okay. Oh, I thought we took care of that. I thought we took care. We're very close to getting this done. Okay. So is it model.device? Maybe we can say that to CPU. How do we say to CPU? Let's see here. Let's try this. To torch.cpu device. All right, thank you for Lexi, guys. Not familiar with this part. Is it asking you specifically the device that supports use of the model training or a device where it's supposed to store the outputs? Yes, the storing. It's the data store challenge that we're currently facing. So you know what? Let's double check. I'm going to move it to CPU because I think that's going to be better. I think that's going to be better, CPU. Okay, so this, I think I need to do something like this. This is what I'm missing. Detach.cpu probs. Let's see if I need to do something like that. I think that's the part that I might be missing. So let's see here. Am I doing that? Ah, that's what it is. Okay. So it's still, okay. But target should be in the GPU. That's what we need to do. We need to get this into the GPU. So can we do that? How do we do that? I guess that's the problem. That's the thing that we need to do. Let's see if we can make it happen. Let's see here. Can we, so we do two, where is that at? Here it is. Okay. Let's see if we can get it. Mr. Denmark, what are you saying? What are you saying? You didn't store the modified target back into target unless it does in place. I think it's an in place. I think it's in place. I'm pretty sure it's in place. Pretty sure it's in place. Let's see here. Like that. Boom. All right. Let's see if that works. If that doesn't, then we will try again. We'll try again. And in fact, we'll use the AI here a little bit more to help us out. Okay, so it's the same problem on line 92. Same problem right here. Okay, we're really close. So because of this tells me the logits itself is on the GPU because this is .2 CPU. So all we have to do, maybe, what if we did this? What if we tried it like this? What if we put it here and go like that? So this, Roman, you might be right. You might be right, Roman. Let's find out. So let's try that. Let's check it out, you guys. It's training. We did it. We solved the thing that we wanted to do. We solved the thing that we wanted it to do for the day. Okay, there we go. We did it, you guys. We did it, and I'm looking at the loss, and I'm seeing it's jumping all over the place, so we need to make some changes. Also, our probabilities, they look weird. You guys. Okay, we are making AI trading algorithm from with Python and using PyTorch transformer and the Gemma embedding model. Check it out, you guys. We got it. We got it a step further. We were able to train it on our data. We did it. So now I do see that there is some issues. I see some issues, the probabilities, I guess, on the output, which gives us some things to learn. We need to go back and see. It is giving us some ideas, but the loss, it looks like it is not what I want it to be. Good news is we'll be able to optimize this, and that'll be the plan for Monday's stream. But the good news is, let's run it again just to check it out. Closer. We are closer. You got it. Uvis, we're closer. We're getting there. So we need to make some adjustments to our data to see how it works, because I want to see that loss number stay low. We want to see that loss number low, and then maybe do some other things. Wow, I know we did it. You guys, look, it's so cool. It trains pretty fast too. Look how fast that trains. And it's all running through a Gemma embedding model. Isn't that crazy? So we're even doing this inefficiently. Do you post code? Yeah, we do. Russell, so let's do that really quick. Get status. Here we go. Get add. Get add train. There we go. And get add readme and download and requirements. Get status. Get commit. And then we did added training. We did it. Let's do that. Thank you for all the likes, you guys. We did it, guys. We did it. Get commit -- amend. Let's do this. Add a training. I forgot to add the party poppers. We got to add the party poppers before we push that. All right, push to, there it is. There it is, you guys. We did it. We were successful. Here you go. It's in our Discord. If you want the link, it is in our Discord.